Hello dear students, welcome back to the online classes. This is the fourth lecture on the topic sequence and series. In today's class, we are going to study some of the examples based on the geometric progression. In the last class, we have studied the definition of the geometric progression, the general terms of the geometric progression, the nth term of the geometric progression, and also sum to n terms of GP. And we have solved some basic examples based on geometric progression. Today, we are going to solve few more questions or few more examples on GP. In the last class, we have seen the general terms of a GP are A, AR, AR square, and so on, A into R to the power n minus 1, where A is called the first term of the geometric progression, that is, it is A. Second term is AR, third term is AR square, and so on, AR to the power n minus 1. Here A is called the first term and R is called the common ratio. We denote it by the notation CR. Common ratio is denoted by the notation small letter r, and it is given by the formula any term divided by its previous term, or AR square divided by AR, that gives A cancel, R get cancels, which gives R. If the ratio between any two terms remains constant, then such progression is called a geometric progression. And the nth term of the geometric progression is denoted by the notation AN or TN, and it is given by the formula A into R to the power n minus 1. The sum to n terms of a GP is given by the formula, or it is denoted by the notation Sn is equal to A into, we denoted by the formula Sn is equal to A into first term into 1 minus R to the power n divided by 1 minus R if R is less than 1. And another formula Sn is equal to A into R to the power n minus 1 divided by R minus 1 if R is greater than 1. These are the two formulas to find the sum to n terms of the geometric progression. With the help of these formulas, today, my dear students, we are going to solve the few examples. Dear students, let me begin with the first example, that is the solved example from the textbook. Find the sum of the first n terms and the sum of the first 5 terms of the geometric series. The given series is consisting 1 plus 2 by 3 plus 4 by 9 plus so on. Here A is called the first term, A is equal to 1, and the common ratio R is equal to any term divided by its previous term, that is 2 by 3. Therefore, the sum to n term is given by the formula Sn is equal to A into 1 minus R to the power n divided by 1 minus R. Since the ratio is less than 1, therefore the sum to n term is given by the formula Sn is equal to A into 1 minus R to the power n divided by 1 minus R. By replacing the values of A and R, 1 minus 2 by 3 raised to n divided by 1 minus 2 by 3, which is equal to the solving the denominator we get. It is 1 by 3, and the 3 of the denominator goes to the numerator. Therefore, 3 times 1 minus 2 by 3 to the power n. This is the sum to n terms of the given geometric series. In particular, we want to know the sum to 5 terms of the given series. S5 is equal to A into 1 minus 2 by 3 raised to n, that is 5, divided by 1 minus 2 by 3. That is 1 minus 2 by 3 is nothing, already we are written as a 3 there. Or in the above formula, you replace n is equal to 5, we'll get S5 is equal to 3 into 1 minus 2 by 3 raised to 5. That gives 3 into 211 divided by 243, which gives 211 divided by 81. This is 211 divided by 81 represent the sum to 5 terms of the given geometric series. Dear students, let me begin with the one more question, which is a solved example from the textbook. Once again, how many terms of the GP 3, 3 by 2, 3 by 4 and so on are needed to give the sum 3069 divided by 512? Now we have to find the number of terms whose sum is 3069 divided by 512. The sum of how many terms gives this sum is. Here we should find the value of n. Let n be the number of terms needed, given that a is the first term, ratio is 1 by 2 and sum Sn is given by 3069 divided by 512. Therefore, since here the ratio is less than 1, the Sn is given by the formula a into 1 minus r to the power n divided by 1 minus r. Therefore, Sn is 3069 divided by 512 is equal to a is our 3, 1 minus 1 by 2 raised to n divided by 1 minus 1 by 2. 1 minus 1 by 2 gives 2 and that 2 1 by 2 goes to the numerator, that gives 3 to the 6 into 1 minus 1 by 2 raised to n. Therefore, the sum how many terms, we want to know how many terms of this series is so and so. Therefore, we have to equate 3069 divided by 3072 is equal to 1 minus 1 by 2 raised to n. By solving this equation, we get 1 by 2 raised to n is equal to 1 minus 3069 divided by 3072. By taking the ratio of these two, that gives 3 divided by 3072 is equal to 1 divided by 1024. By equating 1 by 2 raised to n with 1 by 1024, that gives 2 raised to n is equal to 1024. But 1024 is nothing but having the base 2 to the power 10. By comparing the left hand and right hand side, 2 raised to n is equal to 2 raised to 10. Therefore, n is equal to 10. Therefore, there are the sum to 10 terms whose addition is 3069 divided by 512. Dear student, this is an important question for the exam point of view. Example number 14, which is solved from the textbook. The sum of the first three terms of the GP is 13 by 12. My dear students, here we have been given sum of the first three terms, which is 13 by 12. That is S3 is equal to 13 by 12. Product is the sum of the product of the first three term is minus 1. Ratio and the number of let A by R, AR be the first three terms of the geometric progression. Then it is given that the addition of all these three terms is equal to 13 by 12. Let me denote it by the equation number 1. Again, by the second condition, the product of the same terms A by R, A into A by AR is equal to minus 1. RR get cancels, A cube is equal to, it is minus 1. Therefore, here from 2 we get A cube is equal to minus 1, that is A is equal to minus 1. Considering only one root of this equation, substituting A is equal to minus 1 in the equation number 1, we have minus 1 by R minus 1 minus R is equals to 13 by 12, which is nothing but that because here A by R, A is minus 1 divided by R, A is again minus 1 into R minus R, which is equal to 13 by 12. By solving this equation, we get the quadratic equation in R, 12R square plus 25R plus 12 is equal to 0. This is the quadratic in R. Solving, we get R is equal to minus 3 by 4 or R is equal to minus 4 by 3. Thus, the three terms of the geometric progressions are, if the first term is A by R, A is nothing but our minus 1 divided by minus 3 by 4, that gives plus 4 by 3. Then A is minus 1. Then AR, A is minus 1 into R is minus 3 by 4, that gives 3 by 4. Or we have the series like 3 by 4 minus 1 and 4 by 3. These are the three terms of the given geometric progression. Dear students, let me begin with the question number 15. Find the sum of the sequences. We want to know the sum of these sequences: 777, 777, 7777, so on up to n terms. We want to find the addition of all these three terms. This is not a GP. However, we can relate it to a GP by writing the terms as Sn is equal to 7 plus 77 plus 777 plus 7777 plus so on up to n terms. Now by multiplying and dividing by 9, we get Sn is equal to 7 by 9. We take the common 7 from the numerator 7 and multiply by 9 and divide by 9. We get 9 plus 99 plus 999 plus 9999 plus so on up to n terms. Therefore 7 by 9 outside add it is 9 can be written as 10 minus 1 plus 99 can be written as 100 square, that is 10 square minus 1 plus 10 cube minus 1 plus 10 to the power 4 minus 1 plus so on up to n terms. Now by looking at this equation, 7 by 9 into it is 10 plus 10 square plus 10 cube plus so on up to n terms, and there are the terms which are constant minus 1 minus 1 minus 1 minus up to n terms. Minus sign taken outside, therefore 1 to n terms we have. Therefore 7 by 9, the first bracket that gives the sum to n terms of the geometric progression, and here the first term is 10. Since the ratio is greater than 1, therefore we have the formula 10 to the power n minus 1 divided by 10 minus 1 minus the second term 1 repeated n many times, therefore it is minus n. That is nothing but 7 by 9 into 10 to the power n minus 1 divided by 10 minus 1 is 9 minus 9. This is the general formula for to find the sum to the given series, that is 777, 7777 and so on. Dear students, let me begin with one more example. A person has 2 parents, 4 grandparents and 8 great-grandparents and so on. Then the number of his ancestors during the 10 generations preceding his own. Here A is 2, ratio is 2, and the number of terms, that is for how many generations? 10 number of generations. Therefore n is equal to 10. Here we can write this as, using the sum formula, Sn is equal to A into R to the power n minus 1 divided by R minus 1. Since the ratio is greater than 1, we have the sum to n term formula is A into R raised to n minus 1 divided by R minus 1. Replacing that gives Sn is equal to A is 2, 2 to the power 10 minus 1 divided by, again it is 2 minus 1. Therefore it gives by further simplification 2 raised to n nothing but 2046. Hence the number of ancestors preceding to the person is 2046. Now my dear students, let me begin with exercise 9.3, the first question. Find the 20th and nth terms of the GP. Given GP is 5 by 2, 5 by 4, 5 by 8. Answer. In this case, the given progression is nothing but 5 by 2, 5 by 4, 5 by 8 and so on. Here A is called the first term, which is nothing but 5 by 2. And the ratio of this sequence or this series is any term divided by its previous term, that gives 1 by 2. Since the ratio is less than 1, then we have the sum to n term formula, that is the 20th term of the given progression is A20 is equal to A into R to the power n minus 1. But n is nothing but 20, therefore here A is 5 by 2. 5 by 2 into ratio is 1 by 2 raised to 20 minus 1, that gives 19. After simplification of this, it will be 5 divided by 2 into 2 raised to 19, or it is equal to 5 divided by 2 raised to 20. The nth term of the same progression is given by the formula an is equal to A into R to the power n minus 1. Replacing the first term and the ratio, then we have the sum to, that is nth term of the given progression is 5 divided by 2 into 2 raised to n minus 1. By laws of indices, the denominator can be solved. 5 divided by, since the bases are same in the denominator, the powers get added, therefore that gives 2 raised to n. Therefore an of the given progression is nothing but 5 divided by 2 raised to. Dear students, let me solve the one more example. Find the 12th term of a GP whose 8th term is 192 and the common ratio is 2. Let me begin with the solution of this problem. The given common ratio is R is equal to 2. Let A be the first term of the geometric progression and The eighth term of the given geometric progression is a8 is equals to a into r to the power n minus 1, that is 8 minus 1, that gives 7. Therefore, it is a into r to the power 7. Since a into r to the power 7 is 192 and the ratio is replaced by 2 and the term is 7, by simplification we get the first term of the given progression, that is a is equal to 2 raised to 6 into 3 divided by 2 raised to 7, that gives 3 by 2. The first term of the given progression is 3 by 2. But we want to know the 12th term of the given progression. A12 is equals to a into r to the power 12 minus 1. A is 3 by 2, ratio is 2 raised to 12 minus 1 is nothing but 11. Therefore 3 into 2 raised to 10, that gives 3072.